Hi children, this is yours Kona Kiran Reddy. Welcome to class 8 mathematics. Here in this class, let us do problem number 6 from exercise 6.3. First, let us read the problem. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also, find the square root of the square number so obtained. So here we are given some numbers. What we need to do is, suppose if we take one number that is 252, suppose let us take. This is not a perfect square. We need to divide this number by some number so that it becomes a perfect square. Let me take one example. Suppose we have 72. We need to divide this into factors suppose. So let us start with 2. 2 times 3 is 6. 7 minus 6 is 1. So that will be 12. 2 times 6. So then 2 times 18. Then 2 times 9. Then 3 times 3. So 72 can be written as 2 times 2 times 2 times 3 times 3. Now if you observe, 2 and 2 are pairs. 3 and 3 are pairs. Now we have 1, 2 which is alone. If we divide 72 by 2, so what happens? This becomes 2 times 2 times 2 times 3 times 3 divided by 2. So 2 and 2 gets cancelled. So here this is equal to 2 times 2 times 3 times 3. Here these are in pairs. So the resultant number will be a perfect square. So that is what we need to do here. After that we need to find out the square root of that number also. Now let us solve the first problem. Solution. So let us resolve 252 into factors. So start with 2. 2 times 1 and 2 times 2 is 4. So if you subtract 4 from 5, 1 will be there. Beside we have 2. So 12. So 2 times 6. Then again start with 2. 2 times 6 is 12 and 2 times 3 is 6. Now it is not divisible by 63 is not divisible by 2. So let us take 3. 3 times 2 is 6 and 3 times 1 is 3. So then again 3 times 7 is 21. Now we can write 252 equal to 2 times 2 times 3 times 3 times 7. You observe here 2 and 2 are paired and 3 and 3 are paired. This 7 is alone, that means it is single. Now if you divide 252 by this 7, then this 7 will be cancelled and it will become a perfect square. Why? Because all the remaining numbers will be in pairs. So 252 is to be divided by 7 so as to make it perfect square. So let us divide. 252 divided by 7 equal to 2 into 2 into 3 into 3 into 7 divided by 7. So 7 and 7 gets cancelled. This is equal to 2 into 2 means 2 square into 3 into 3 is 3 square. So this is equal to 2 into 3 whole square, which is equal to 6 square. So therefore square root equal to square root of what? Square root of the resultant number when 252 is divided by 7. So square root of that number will be equal to how much? 6. So this is the answer. Now let us do the second problem. That is 2925. Now let us divide this 2925. Let us divide this. If you observe this one, the digit in units place is 5. So it is not divisible by 2. So let us check with the 3 whether it is divisible by 3 or not. So for that what we need to do? Add the digit. 2 plus 9 plus 2 plus 5 equal to 2 plus 9 is 11. So 11 plus 2 is 13. 13 plus 5 is 18. So 18 is divisible by 3. So this number is also divisible by 3. So let us take 3. So 3 times 9 is 27. So 27, if it is subtracted by 29, 2 will be there. Beside that we have 2, so 22. 3 times 7 is 21. So if we subtract 21 from 22, 1 will be remaining. Beside that 5 we have. So 15. So 3 times 5 is 15. Now let us divide this again by 3. 3 times 3 is 9. 3 times 2 is 6. 1 will be there. 15. So 3 times 5 is 15. Now if you add 3, 2, 5, what happens? What will be remaining? That is equal to 10. It is not divisible by 3. So 325 is not divisible by 3. So let us do with 5. 5 times 6 is 30. Then 5 times 5 is 25. Now again do with 5. 5 times 1 is 5. 15 will be there. 5 times 3 is 15. So therefore we can write 2925 equal to 3 times 3 times 5 times 5 times 13. So here 3 and 3 are one pair. 5 and 5 is one pair. So the remaining one is 13, which is alone, which is single. If we remove this 13, then the remaining number will become a perfect square. Why? Because the remaining number will be in pairs. So to make 2925 a perfect square, we need to divide this number by 13. So therefore 2925 is to be divided by 13 to make it a perfect square number. A perfect square. So let us divide. So 2925 divided by 13 equal to, if we divide this by 13, what are the remaining prime factors? 3 times 3 times 5 times 5. So this is in pairs. This is equal to 3 square times 5 square, which is equal to 3 times 5 whole square, which is equal to 15 square. So therefore square root of obtained number equal to, that is nothing but 15. Okay, let us move on to next problem. Next, third problem, that is 396. Let us divide 396 into factors. So 396, it is divisible by 2. So 2 times 1 is 2. 3 minus 2 means 1. Beside 9 we have 19. 3 times 9 is 18. 1 will be there if you subtract 8 from 9. If you subtract 18 from 19, 1 will be there. Beside that 6 we have. So 16. 2 times 8 is 16. Let us do again with 2. 2 times 9 is 18. Again 2 times 9 is 18. 99 is not divisible by 2. So let us do with 3. 3 times 3 and 3 times 3. Then again with 3. 3 times 1 and 3 times 1. So therefore 396 equal to 2 times 2 times 3 times 3 times 11. So here 2 and 2, this is one pair, and 3 and 3, this is another pair. So 11 remained unpaired. So it is single. So if you remove this 11, we can get the remaining number as a perfect square. How to remove this 11? Just divide 396 by 11. So therefore 396 is to be divided by 11 so as to make it perfect square. So let us divide. So 396 divided by 11 will be equal to 2 into 2 into 3 into 3, not into 11. Why? Because we divided this number by 11, so it will be cancelled. So don't write 11 here. So this is equal to 2 into 2 is 2 square into 3 is 3 square. So which is equal to 2 square into 3 square. This is 2 into 3 whole square, which is equal to 6 square. So therefore square root of the number obtained equal to how much? 6. That's it. Let us move on to the next problem. What is the next problem? Fourth one, that is 2645. So we need to resolve this into factors. 2645. First, let us start with 2. It will not be divisible by 2. Let us try to divide with 3. Now to check whether this one is divisible by 3 or not. So we need to add the digits. 2 plus 6 is 8. 8 plus 4 is 12. 12 plus 5 is 17. 17 is not divisible by 3. So let us try with 5. Why? Because in the units digit we have 5. So it will be divisible by 5. So 5 times 5 is 25. 25 subtracted from 26 gives 1. So beside that 4 we have 14. So 5 times 2 is 10. 4 will be remaining. 45 means 5 times 9 is 45. Now 529 we have. If you try to divide this with the prime numbers, it will be divisible by only 23. So 23 is equal to 529. Now therefore 2645 equal to 5 times 23 times 23. So here 23 and 23 are in pair. The only remaining unpaired number is 5. So if you divide this number by 5, then this 5 will be cancelled and the remaining number 23 into 23 will be a perfect square. So therefore 2645 is to be divided by how much? 5, so as to make it perfect square. Now let us divide 2645 by 5. So 2645 divided by 5 equal to, you see the prime factors here. This number is divided by 5 means 5 will be cancelled. So the remaining value will be 23 into 23. So that is equal to 23 into 23, which is equal to 23 square. So therefore square root of the resultant number equal to how much? 23. We can write square root of the resultant number or square root of the number so obtained. Like that also we can write. Both are same. Okay, so 23 is the answer in this case. Now let us move on to the fifth question. So fifth problem is, what is that? 2800. So let us resolve this into factors. Let us divide this into prime factors. First start with 2. 2 times 1, 2 times 4, 0, 0. Then again with 2. 2 times 7 is 14, so 0, 0. Then 2 times 3 is 6. 1 will be there. Besides 0 we have, so 10. 2 times 5 is 10 and then 0. Then again divide by 2. So 2 times 1 is 2. So 3 minus 2 means 1. Beside that we have 5. So 15. 2 times 7 is 14. 1 will be remaining. So 10. 10 means 2 times 5 is 10. Then if you take 175, it is not divisible by 2. So let us start with 3. Actually 1 plus 7 plus 5 is 1 plus 7 is 8. 8 plus 5 is 13. It is not divisible by 3. So this number 175 is not divisible by 3. So take 5. So 5 times 3 is 15. 25 will be there. 5 times 5. Then 5 times 7 is 35. So we can write therefore 2800 equal to, we can write this one as 2 times 2 times 2 times 2 times 5 times 5 times 7. Now take pairs. So 2 and 2 is one pair. Then again 2 and 2 is one pair. 5 and 5 is one pair. So the 7 will be the remaining value which is alone, which is single, which is not paired. So if you divide this value by 7, then this 7 will be cancelled and the remaining values will be in pairs. So the remaining number will be a perfect square. Now, so we need to divide this 2800 by 7 so as to make it perfect square. So therefore 2800 is to be divided by 7 so as to make it perfect square. Okay, so let us divide. So 2800 divided by 7 will be equal to, here in the prime factorization 7 will be cancelled. Why? Because we divide 2800 by 7. So this will be 2 times 2, 2 times 2 times 5 times 5. So let us take pairs. So this is equal to 2 square into 2 square into 5 square, which is equal to 2 into 2 into 5 whole square. So this is equal to 2 times 2 is 4, 4 times 5 is 20. So 20 square. So therefore square root of the obtained number, so equal to how much? That will be 20. So that is the final answer. Okay, let us go to the next problem. That is the last problem, that is sixth problem, 1620. So let us divide this 1620 by 2. So 2 times 8 is 16, 2 times 1 is 2, then 0. So then again do with 2. So 2 times 4 is 8, 1 is there, 1 is not divisible by 2. So take 0 here and now take the next 0 also, that means that is 10. So 2 times 5 is 10. Then 405 is not divisible by 2. So 4 plus 5 equal to 9. 4 plus 5 equal to 9. 9 is divisible by 3. So 405 is divisible by 3. So divide this 405 by 3. 3 times 1 is 3. 4 minus 3 means 1. Beside 0 means 10. So 10 means 3 times 3 is 9. Again 10 minus 9 means 1 will be remaining. So beside that we have 5, 15. So 3 times 5 is 15. Then again divide this one by 3. So 3 times 4 is 12. Then 1 will be remaining 15. 3 times 5 is 15. Again divide by 3. So 3 times 1 is 3 and 3 times 5 is 15. So 3 times 5 is 15. So therefore 1620 equal to, write all these prime factors. 2 into 2 into 3 into 3 into 3 into 3 into 5. Make pairs. So here 2 and 2 is one pair, 3 and 3 is another pair, 3 and 3 is also another pair. So what is the remaining unpaired value? That is 5. So if you divide this 1620 by 5, so this 5 will be cancelled and the remaining values will be in pairs. So it will be a perfect square. Okay. So therefore 1620 is to be divided by 5 so as to make it perfect square. So let us divide 1620 by 5. So 1620 divided by 5. So that will be here in the prime factorization, divided by 5 means this 5 will be cancelled. So write the remaining values. So let us write this is equal to 2 times 2 times 3 times 3 then times 3 times 3. So now make pairs. So this is equal to 2 square into 3 square into 3 square. So that is equal to 2 into 3 into 3 whole square, which is equal to 2 into 3 is 6, 6 into 3 is 18. So 18 square. As we got 18 square, the square root will be 18. So therefore, square root of the number so obtained equal to how much? That is 18. So this is the, I hope you understand the problem. So I hope you understand my explanation. If it is so, thank you. Thanks for watching.